Okay, number 20. Because all of those exponents are the same, they can all be in the same parentheses, and the exponent can go to the outside. And in here you have 2 times 16 divided by 4. 2 times 16 is 32 divided by 4. 32 divided by 4 is 8. So this is 8 to the exponent 2/3. That is the same thing as the third root of 8 and then squared. Well, we know that 8 is 2 times 2 times 2. There's one circle, and don't forget that this is going to be squared. This is going to come out, and so that's 2 squared is 4. Okay, if you're adding 4 root 24, it's the cubed root, plus 5 cubed root of 3, you can't add those because those terms aren't alike. But that first term looks to me like it will reduce, and so I'm going to find the prime factors of 24. 2 goes into there 12 times. 2 goes into 12 6 times. And 2 goes into 6 3 times. And so that is 4, the cubed root of 3 2's, and 1 3. Because that index is a 3, there has to be 3 items in the circle. You have one circle, so one number goes out with the 4. So it's 4 times 2, cubed root of 3. Well, what is 4 times 2? That is 8 times the cubed root of 3, and that is the first term, plus 5 times the cubed root of 3. Now they're both cubed roots of 3, so they're like terms. 8 plus 5 is 13, cubed root of 3. Number 22, you can't subtract those because those aren't like terms, but we could probably reduce 1,701, so I'm going to check. It's the fifth root, and for it to reduce, you can see that it's got to be divisible by 7 for it to help us out at all. And so, no, I'm going to change colors. So we're going to do 1,701. See if a 7 divides into it. If a 7 doesn't divide into it, it won't help us. It just won't reduce. So 1,701 divided by 7 is 343. Divide that by 7. Nope, doesn't work. Okay, 343 we'll divide by 3. Oops, I said 343. That is 243. So that will divide by 3, and it goes into there 81 times. 3 goes into 81 27 times. 3 goes into 27 9 times. And 3 goes into 9 3 times. So that is the same thing. The 2's on the outside, and you have 1, 2, 3, 4, 5 3's. Times root 7. Because the index is 5, you have to have 5 of the same thing in a circle before you can bring anything out. You have one circle of 3's, so it comes out with the 2. It's 2 times 3 to the fifth root of 7, which is 6 to the fifth root of 7. And that's what the second term is. So we have 8 fifth root of 7 minus 6 times the fifth root of 7. Okay, they're both the fifth root of 7. 8 minus 6 is 2 times the fifth root of 7, and that's your final answer. On 23, you would have, because the index is the same, you could do it more than one way. You can multiply 6 times 8, put it under the radical and reduce it. But I already know I'm going to have to reduce it. So instead of multiplying and then start dividing, I'm just going to divide first. 6 can be written as 2 times 3. 8 can be written as 2 times 2 times 2. So in all, it's all under the fourth root. You have 1, 2, 3, 4 2's and 1 3. You have to have 4 of the same number to make a circle. You have one circle, so you have one number on the outside. It's the fourth root, and there's a 3 left on the inside. Okay, the cubed root of 3 times the cubed root of 18. I'm going to put it all under one radical. This is the cubed root of 3. 18 could be rewritten as 2 times 3 times 3. And if I put it all under one radical, it's the cubed root of 2 times 3 3's. Anything there's 3 of, you put in a circle. There's one circle, so there's one number on the outside. And this is the cubed root of 2.